In this short clip, I'm going to explain what the number needed to treat is and how it is calculated. The number needed to treat, or more commonly abbreviated NNT, is a medical statistic used to compare different interventions in randomized control trials. It denotes the number of subjects who would need to be treated with an intervention, for example drug therapy or surgery, over a defined time period in order for one patient to achieve treatment success. This is typically compared to a control, for example no treatment, placebo or standard intervention. So how do we calculate the number needed to treat? Let's imagine we run a trial and some people take the trial drug and others take a placebo drug. The character icons that are blue represent those that developed the outcome of interest, and the character icons that are grey represent those who did not. Counting the character icons, we can see that 5 of the people taking the trial drug developed the outcome and 15 did not. In those who took the placebo drug, we can see that 10 people developed the outcome and 10 did not. The total people in each group was 20. To calculate the number needed to treat, we divide 1 by the absolute risk reduction. Recall that the absolute risk reduction is calculated by subtracting the probability of developing the outcome in the placebo group from the trial group. So in this example, the control event rate is 10 over 20 and the experimental event rate is 5 over 20. By substituting into the equation, we find that our number needed to treat is 4. This means we need to treat 4 people in order for one person to receive the treatment benefit. Here is an example of an NNT in the medical literature. The NNT itself is rounded up to the nearest whole number, and we can tell that the NNT is statistically significant if the 95% confidence interval does not cross 1, or when the p-value is less than 5%. Simply put, the NNT can help us decide whether a treatment is effective by weighing the risks against the benefits. We derive the greatest benefit from the lowest NNT. In this pilot trial, we have developed a few NNT-based tools which depict data from systematic reviews in pictographs. Each aid has 2 interfaces, a practitioner and patient view. The patient view displays the NNT as a proportion. For example, in this case, 4 out of 10 people who use antibiotics for bacterial conjunctivitis felt better within 2 to 5 days, compared to 3 out of 10 people who did not use antibiotics. Other features include information on side effects, patient self-care, patient referral, and other practice points. The practitioner view is a little more complex. On the top left-hand corner, we have the number needed to treat. Other features include the study characteristics represented in a PICO framework, a calculation section, and a summary of the results. Pharmacists can also find an outline of the available OTC dosage forms, pregnancy classification, and other resources to consider. This brings us to the end of the NNT introduction video. We look forward to your participation in the upcoming project.